Hello my dear students, welcome back to our channel. So we discussed inverse functions and their derivatives. How to find inverse of a function, how to graph a function and its inverse, how to find derivatives of inverse of a function without finding the inverse, etc. So today we can discuss some problems on derivatives of inverse functions. Derivatives of inverse functions. Before going to the questions, please do subscribe to our channel. Okay, see the question. In the following exercise, first part find f inverse of x, second part graph f and f inverse together. C. Evaluate df by dx at x is equal to a and df inverse by dx at x is equal to f of a to show that at this point df inverse by dx is equal to 1 by df by dx. So first question, f of x is equal to 2x plus 3, a is equal to minus 1. So we have to find f inverse of x. To find f inverse of x, put y is equal to 2x plus 3. Then express x in terms of y. That is 2x is equal to y minus 3. Or we can say x is equal to y minus 3 by 2. X is equal to y minus 3 by 2. Interchange x and y. So we get f inverse of x is equal to x minus 3 by 2. So this is f inverse of x. Next B part, graph f and f inverse together. So to draw the graph of f of x, we can find the coordinates. Y equal to 2x plus 3. When x is equal to 0, y is equal to 3. So 0, 3 is a point. When x is equal to 1, y equal to 2 plus 3, 5. So 1, 5. When x is equal to minus 1, minus 2 plus 3. That is 3 minus 2, 1. So minus 1, 1 is another point. When x is equal to 2, 4 plus 3, 7. So 2, 7. When x is equal to minus 2, 3 minus 4. That is minus 1. Minus 2, minus 1. This much points enough. So we can draw f of x. Y-axis, x-axis. 0 up to 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Minus 1, minus 2, minus 3, minus 4, minus 1, minus 2, minus 3, minus 4. Okay, we can grow. So first 0, 3. 0, 3. This point 1, 5. 1, 5. This point 2, 7. Minus 1, 1. Minus 2, minus 1. This point. So this is f of x. This is a rough sketch. So how to draw f inverse of x? We know in f of x and f inverse of x, x coordinate and y coordinate get reversed. That is, if minus 2, minus 1 is a point in f of x, minus 1, minus 2 is a point in f inverse of x. So we can draw first minus 1, minus 2. Minus 1, minus 2. Minus 1, 1 will become 1 minus 1. So 1 minus 1. Second 3, 0. 5, 1. 7, 2. So this is the graph of f inverse of x. We know f of x and f inverse of x are symmetric about the line y equal to x. That is, if we draw the line y equal to x and we put a mirror in this line, then it will be the mirror image of one another. C part. Evaluate df by dx at x is equal to a. We have to find the derivative at x is equal to a is minus 1. So df by dx is equal to d by dx of 2x plus 3, that is 2. At a equal to minus 1, this is 2. Now df inverse by dx. F inverse of x is x minus 3 by 2, that is d by dx of x minus 3 by 2, that is 1 by 2 into 1 minus 0, that is 1 by 2. At x is equal to f of a, df inverse by dx is equal to 1 by 2 itself. No values of x here. Show that at this point df inverse by dx is equal to 1 by df by dx. Clearly df inverse by dx is equal to 1 by df by dx. This was studied, that is they are reciprocal of one another. Second question, f of x is equal to 1 by 5x plus 7, a equal to minus 1. So first part, find f inverse of x. F inverse of x is put y is equal to 1 by 5x plus 7, express x in terms of y, that is 1 by 5x is equal to y minus 7. So we get x is equal to 5 into y minus 7. So f inverse of x is equal to interchange x and y, that is 5 into x minus 7. So this is f inverse of x. Second part, graph f and f inverse together. Before that we can see third part, C. Evaluate df by dx at x is equal to a. df by dx is equal to 1 by 5 into 1 plus 0, that is 1 by 5. At x is equal to a, this value, and df inverse by dx is equal to d by dx of 5x minus 7, that is 5. So df inverse by dx is equal to 1 by df by dx. Here at a and f of a. Here there is no x in df by dx and df inverse by dx. So at x is equal to a and f of a, same value. So they are reciprocal of one another. Now we can graph f and f inverse. To graph f, we can find the points. When x is equal to 0, point is 1 by 5 into 0 plus 7, that is 7. 0, 7 is a point. When x is equal to 5, 1 plus 7, that is 8. 5, 8 is a point. When x is equal to minus 5, we get minus 1 plus 7, that is 6. So minus 5, 6 is a point. So we can draw the graph. 2, 4, 6, 8. So 0, 7. 0, 7 is this. So this point. 5, 8. 5, 8. Minus 5, 6. Minus 2, minus 4. So minus 5 here, 6. So this is the line f of x. So f inverse of x is the points get reversed, that is 6 minus 5. 6, 2, 4, 6. Here is minus 5. 6 minus 5. 7, 0. 7, 0. And 8, 5. 8, 5. So this is f inverse of x. Symmetric about the line y equal to x. Third question, f of x is equal to 5 minus 4x. So we have to find f inverse of x. F inverse of x is put y is equal to 5 minus 4x. Then express x in terms of y. That is 4x is equal to 5 minus y. or we can write x is equal to 1 by 4 into 5 minus 1. So f inverse of x is equal to interchange x and y, that is 1 by 4 into 5 minus x. So this is f inverse of x. Now we can draw later C part. Evaluate df by dx and df inverse by dx at x is equal to a and f of a respectively. So df by dx is equal to d by dx of 5 minus 4x, that is minus 4, and df inverse by dx is equal to d by dx of 1 by 4 into 5 minus x, that is minus 1 by 4. So clearly they are reciprocal of one another. 1 by df by dx. Here at x is equal to a df by dx, at df by dx at x is equal to f of a. How to find f of a? See here, for example, I will show. Here a equal to 1 by 2 given in the question, but we are not used here. A equal to 1 by 2 given. So what will be f of a? F of a is 5 minus 4x at x is equal to 1 by 2. That is 5 minus 4 into 1 by 2. That is 4 by 2 is 2. That is equal to 3. Like that you can find f of a. Now see the graph. So first coordinate, when x is equal to 0, point is 5. So 0, 5 is a point. When x is equal to 1, 5 minus 4, 1. So 1, 1 is a point. When x is equal to 2, 5 minus 8, that is minus 3. So 2 minus 3 is a point. Like that, when x is equal to minus 1, 5 plus 4, that is 9. Minus 1, 9 is a point. Like that we can find the points. So the graph is 0, 1, 2, 3, 4, 5. 0, 5. 0, 5. 1, 1. 1, 1. 2 minus 3. So you can draw the graph like this. This is the graph f. Now f inverse, just reverse the points. So 5, 0, 1, 1, this point, minus 3, 2, minus 1, minus 2, minus 3, minus 3, 2. So this is the graph. I'm just making a rough sketch, okay? So this is f and f inverse of x. Next question. First part, show that f of x is equal to x cube and g of x is equal to cube root of x are inverses of one another. To show they are inverses of one another, it's enough to check f of g of x is equal to g of f of x is equal to identity function. That is f composite g and g composite f is equal to identity. So we can check f of g of x is equal to f of g of x is cube root of x is equal to f of x is x cube. So f of cube root of x is cube root of x the whole cube, which is equal to x identity. Like that, g of f of x is equal to g of f of x is x cube. G of x is cube root of x. So g of x cube is cube root of x cube, which is equal to x identity. So we can say f and g are inverses of one another. Second part, graph f and g over x interval large enough to show that the graphs intersecting at a 1, 1 and a minus 1, minus 1. We know the graph of x cube and a cube root of x. So we can make x interval large enough to show the points 1, minus 1, we know 1 cube is 1 and minus 1 cube is minus 1. So this graph will be 0 cube is 0, like this. So this is the graph of y equal to f of x or x cube. So 1 1 and minus 1 are points of f of x. So 1 minus 1 points of f inverse of x. So it will be like this is the point, and the graph will go like this. You can expand this. So this will be the graph of f inverse of x. Here the graph goes like this. Okay. Next, C part. Find the slopes of the tangents to the graph of f and g at 1 1 and minus 1 minus 1. What is slope of the tangents? Slope of the tangent is nothing but derivative of f and g. G is nothing but f inverse at 1 1 and minus 1 minus 1. So we can find slope of tangent of f is df by dx, which is equal to d by dx of x cube, that is 3x square, at points 1 1 and minus 1 1. At x is equal to, here 1, at x is equal to 1, we can say this is 3 into df by dx is 3 into 1 square, that is 3. And at x is equal to minus 1, this is df by dx is 3 into minus 1 square, again 1, that is 3 itself. So at 1 1 and minus 1, slope of f is 3. We know slope of tangents of f and f inverses are reciprocal of one another. So we can say this is df inverse by dx is equal to 1 by df by dx at x is equal to 1 and minus 1 respectively. So 1 by 3 at 2 points, at 1 and at minus 1. Slope of tangent of f inverse is 1 by 3. Or we can find it by using the formula. Here f inverse is x raised to 1 by 3. Cube root of x is nothing but x raised to 1 by 3. So df inverse by dx is equal to 1 by 3 into x raised to 1 by 3 minus 1. That is minus 2 by 3. So substitute at x is equal to 1 and at x is equal to minus 1. Last part, what lines are tangents to the curves at the origin? So for f of x, at the origin, tangent is the curve y equal to 0, that is x-axis for f of x. And for f inverse of x, at x is equal to 0, tangent to the curve is the line x is equal to 0, that is y-axis. Next, a similar question. First part, show that f of x is equal to x cube by 4 and g of x is equal to 4x the whole raised to 1 by 3 are inverses of one another. So we can check f of g of x and g of f of x. F of g of x is f of g of x is 4x the whole raised to 1 by 3. And f of x is x cube by 4. So f of 4x raised to 1 by 3 is equal to 4x raised to 1 by 3 the whole cube by 4. This is equal to 4x by 4, which is equal to x. And g of f of x is equal to g of f of x is x cube by 4 and g of x is 4x the whole raised to 1 by 3. So g of x cube by 4 is 4 into, instead of x cube by 4 the whole raised to 1 by 3. Here 4 get cancelled, x cube the whole raised to 1 by 3 is equal to x. So f of g of x is equal to g of f of x is equal to identity function. So they are inverses of one another. Second part, graph f and g over x interval large enough to show the graphs intersecting at a 2 2 and a minus 2 minus 2. So we can draw x-axis and a y-axis. Here 1, here 2, 1, 2. To draw f of x, we can see the points when x is equal to 0, y equal to 0. When x is equal to 2, 2 cube by 4, that is 2 square into 2 by 4, that is 2. So 2, 2 is a point, and when x is equal to minus 2, minus 2, minus 2 is a point. Enough. We can draw 0, 0, 2, 2, minus 2, minus 2. Just like this is the graph. Like that, f inverse of x is just like this. I'm drawing a rough sketch, okay? So this is f inverse of x. Next, we have to find slopes of tangents to the graph of f and g at 2, 2 and minus 2. Minus 2, minus 2. That is at this point. And at this point, we have to find the slope of the tangent. So this is nothing but df by dx. Slope of tangent of f is df by dx, which is equal to 1 by 4 into 3x square. At first the point 2, 2, that is at x is equal to 2. This is 1 by 4 into 3 into x square, 2 square 4, which is equal to 3. Like that, at x is equal to minus 2, this will become 1 by 4 into 3 into minus 2 square. Minus 2 square is again 4, so it is equal to 3 itself. Now df inverse by dx. This will be just 1 by 3. Last question, what lines are tangent to the curve at the origin? Like the previous question, this is at for f the line y equal to 0, and for f inverse the line x is equal to 0. See you in the next video. Bye bye. Please like, share, comment, save and subscribe to our channel. Thank you for watching. Thank you.